All right, so let me show you a shortcut on how to do this time. So take a look. This is the one that we're missing, right? So what I do is I search for a diagonal where I don't have any missing variables. So for example, that's this diagonal, nothing is missing, okay? So what I do is I say C is equal to, and the diagonal where no information is missing is that red one, so it's 9 sine of 100. Now, which one have I not used yet? This one. So I say divided by sine of 53. It works every single time. And I'll do more and more of it so you guys will see throughout this lesson. All right, so this one we plug it into the calculator just like we did the other one. And for this one we get 11.1. So that's 11.1, and there you have it. We just solved the triangle. Woohoo. All right, so let's do another one. Here it says solve triangle NPQ, but we're not given a diagram. Well, let's draw ourselves a diagram. We draw a triangle, and we label the angles NPQ. It really doesn't matter where you put which one. But now, let's see what we have given to put inside. So we have that Q is equal to 110 degrees. That's right there. Now, little q is 11. Well, little q, it has to be opposite to big Q. So here, that's 11. And little n is opposite to big N, and that's 8. Okay? So what I have left then is little p right here. Okay, so what is it here that I need to find? What's missing? Well, I'm missing angle N, I'm missing angle P, and I'm missing little p. Okay? All right, so let's go ahead and find these. All right, let's search for a pair of side angle where we have both given to us, and that you can see is big Q and little q. So we're going to start with that, and we're going to say, all right, sine of Q over little q is equal to, now let's decide which one we want to find. So take a look at P. Both of the pieces for P are missing. That's not a good starting point. N, we have one given and one missing. That's a much better starting point. So we're going to do sine of N over little n. So now, this is going to be sine of 110 over 11 equal to sine of N over 8. Okay? All right. So let's see what it is that we're looking for here. Well, we're looking for sine of N. Okay, that's the unknown. Well, now let's find a way to solve for that. So it's going to be sine of N is equal to, where is the diagonal where everything is given to us? It's that red one. So 8 sine 110 divided by, which one is it that I haven't used yet? The 11. Okay? So now, let's plug that into the calculator here, and we get that sine of N is equal to 0.6834. I'm not doing that in my head. I plugged it into the calculator prior to this. And, so now I'm just giving you the solutions. Okay. Okay, so this is sine of N is equal to that. Well, how do I solve for N? Okay, well, I'm going to look at inverse sine of both sides. That gets rid of the sine. So now, these go away, and N is inverse sine of 0.6834. Okay, so let's plug that into our calculator now. Well, inverse sine is going to be second sine, and then you put in the number. 0.6834, enter. That's 43.1 degrees. Okay, so N is 43.1 degrees. All right, let's put that here. What about P? Okay, so P is easier at this point. So for P, I only do 180 minus 110 minus 43.1, and P will equal to 26.9. Okay, so I'm done with that one. All right, now I need to find little p. For little p, I'm going to do law of sines again. So it's going to be sine of q over q is equal to sine of p over p. So this is going to be sine of 110 over 11 is equal to sine of 26.9 over little p. Okay, p is my unknown. So that equals fraction bar. What's the diagonal where everything is given to me? Here, 11 sine 26.9. Which one haven't I used yet? Sine of 110. We plug it into the calculator, and p is 5.3. Okay, so there we go with that one. All right, let's do one more. This is an interesting one. All right, so it says to solve triangle DEF. This time I'm going to be a rebel, and I'm going to put D up here, and then E, and then F, because it doesn't matter. All right, angle E is 52. Little e, which is opposite to this, is 5. Little f, which is opposite to big F, is 9. Okay, so the pair where I have both given is for e. So it's going to be sine of e over little e equals. Okay, so do I search for d? I can't because none of those is given. Do I search for f? I can do that because one of the pair is given. So it's going to be sine of f over little f. Okay, let's plug in everything we have. Sine of 52 over 5 is equal to sine of f over 9. All right, so what's the unknown? Sine of f is equal to, what's the diagonal where everything is given? Here, 9 sine 52. Which one haven't I used yet? The 5 over 5. All right, so we plug that into the calculator, and we get that sine of f is equal to 1.4184. And here we pause. There's something wrong with this. This is telling us that the sine of the angle f is 1.4. Well, that can't be. Sine can never be greater than 1. Okay? That means we just say no triangle. Right? Sine cannot be greater than 1. So what does it mean, no triangle? Well, it means there is no possible way that you can construct a triangle that has 52 as angle E, 5 as E, and 9 as F. There is no way you can construct a triangle like that. It breaks all the rules of math. Okay? All right. We can use the law of sines to find the area of triangles. So traditionally, when I have a triangle like this, okay, and I want to find the area of it, well, if this is the base of it, then I draw a perpendicular line down, and that is the height. And that is the height. Okay? And then the formula was always A is equal to half base times height. Okay? Well, that's the traditional one. But what if there is no way for you to find any of that information? Well, you're in luck, because there is a whole trigonometric set of formulas, and you can do, you can find the area of those. Okay, so the trigonometric ones are these. We have A equals half BC sine A, half AC sine B, half AB sine C. Okay, before we get to the point where we're freaking out, let's see. The triangle has 3 sides, A, B, 3 sides, A, B, C. Okay, so let's pick a random 2. Let's pick B and C. So you do half, B and C. Which letter haven't I used? A, so it's sine of A. Now let's pick a different pair. A and C. Half, A and C. Which letter have I not used? B, sine of B. Half, AB, sine of C. Okay, so it's very much possible to figure out. All right. How do you know which one of the three you're going to use? Well, that all depends on what information you have at your fingertips. So let's take a look at example 4 here. It says to find the area of this triangle. Let's see what it is that we're given. I'm given A, I'm given little b, and I'm given little c. Okay, so which one of these uses that one? Oh my gosh, it's the first one. So I say area is half BC sine A. So this is equal to half. B is 6, C is 3, sine of 25. Okay, we're going to plug it into the calculator. Now, if you want to do some work beforehand and say half times 6 is 3, so this is really 3 times 3, 9 sine 25, you can do that. Or you can just plug it in from the get-go. And A is equal to 3.8. Remember, this is area. So the units have to be centimeters squared. You just multiplied two sides, so it has to be centimeters squared. All right, let's do this last one. You're not given a diagram. Do you need to draw a diagram? Not really. Let's see what we have. We have little b, we have little c, and we have capital A. It's the same one. So it's A equal to half 18 times 22 times sine of 30 degrees. Now, check this out. Half times 18 is 9 times 25. I don't know what, oh, 22, sorry. Okay, you can plug this in the calculator, but we know what sine of 30 is. It's 1/2, right? So, what's 22 times a half? It's 11. So this is 9 times 11, 99. What are the units? Meters squared. Again, you could have plugged it into the calculator here, but I'm just showing you that you can do this mentally. All right, we're going to stop right here. And as far as homework is concerned, I would like you to do these two, not these two, so 1 to 5 and then 11 to 17 for Thursday. All right, so I'll see you in class Thursday.